Hello, today's lesson is going to be on interpreting graphs. The bulk of this class is based on being able to interpret graphs, to read them, to glean information from them, to use that information in different ways, and to take algebraic manipulations and put them into a graph. So we're going to start with baby steps with some linear graphs to help you get used to identifying key points, to notice the slope, if it's rising, if it's falling, if lines are parallel and perpendicular, what effects some parameter changes have on that, and then we will expand on this as the year goes by. Let's start with some basic algebra. The equation of a line is y equals mx plus b. Now, m is your slope. And I will say on your calculators, and when we get into transformations, slope is referred to as a, not m. So don't let that confuse you. It's just a different way of writing it. Slopes can be positive, negative, undefined, or zero. And remember, the formula for slope was y2 minus y1 over x2 minus x1. And we had positive slopes that went up. We have negative slopes that go down. We have a slope of 0, which is flat. And then we have our undefined slopes, which are vertical lines. The next thing we want to be able to identify is the b value, or the y-intercept. And the y-intercept is where the graph crosses the y-axis. Just like you can intercept a football pass, the graph can intercept the axis, and it is the y-axis. The point looks like 0, y. That's where your value will be. You can move this up or down. That's going to change some other things. I want you to be able to find the x-intercept, and this is where the graph crosses the x-axis. Not the y-axis, the x-axis. And a lot of this stuff, you know, it just takes a while to get it set into your head, and so you don't confuse it with other things. It's a point x0. Remember how these look when they're written. It will make it a lot easier. I also want you to think about parallel and perpendicular lines. In parallel lines, the slopes are alike. They are the same. These are two lines that make railroad tracks that exist in the same plane and never cross. In perpendicular lines, the slopes are negative reciprocals. That means the slopes are opposite from each other, and the value of the slope is a reciprocal to the other value. You also know that m1 times m2 equals -1. These make perpendicular lines, and the symbol for this looks like that. So if you ever see that, that's what I'm talking about. We're going to explore some changes in the parameter of the graph, and to do this, I'm going to use a program called Desmos.com. It's free. It is an online graphing calculator. It's really easy to work with. You can use color. You can type on it. It's very intuitive. So if you ever need help on the graphing at home, I would highly recommend this. So let's switch over to this and play around and see what we see. I'm going to give you a few minutes to pull up Desmos if you want to play on your own. Hopefully anybody who wanted to has gone to Desmos and see if you could find it. It looks like this. Like you see, I've entered in the equation of a line and its graph for you. So let's start by naming our basic parts. What is the slope of the line? Well, according to our equation, the slope is 4. Could I find that algebraically? Certainly. What you need to do is find 2 points on the line and then use your algebraic equation. I'm going to show you which 2 points I would recommend because we're going to find them anyway. What is your y-intercept? In this case, the y-intercept is where the graph crosses the y-axis, and that is the point 0, 2. You need a y value there because it's the y-intercept. What's the x-intercept of this graph? The x-intercept is the point. It's a little harder to see on this one, but -1/2, 0. Now if I wanted to find the slope algebraically, I would use my formula, and we'll do that right over here just for a little extra practice. So 0 minus 2 divided by -0.5 minus 0 equals -2 minus -1/2. And this is why decimals are hard to work with. Now watch if I'd use this as a fraction, how much simpler this would be. -2 divided by -1/2. When you're dividing a fraction by a fraction, to work with that, you take your numerator and you multiply it by the reciprocal of the denominator, or in this case, -2/1, so my slope is 4. And that's exactly what I came up with earlier. Some other important things to notice. The slope is 4, so the graph is rising in a positive manner. There aren't two lines to compare. Any point on this line that you pick has to satisfy this equation and make it a true statement. So if I give you a point, let's just say the point 0, -4, and I ask you if that's a point on the line, how would you determine that? Plug it into your equation. So if x is 0, we would get 0 plus 2. 2 does not equal -4, so that is not a point on the line. Lots of things you can tell from this. You just have to get used to looking at it. All right, I've added in another line with Desmos, and I want to show you some things you can do with it. I've added in the equation y equals mx plus b, and I've added some sliders. So this is my orange line right here. Again, there's my y-intercept of 0, 1. There's my x-intercept. You notice we have our slope, which is the b, and our y-intercept, which is, slope, which is m, and y-intercept, which is b. If I want to change the m value, I've projected a slider right here. Watch what happens is I make my slope get smaller. If the slope is 0, the line is flat. If I move the slope to -2, it's negative. And we will play with this in class a little bit, but you can see as you move this around the effect it has on the graph. To make it parallel, I would use a slope of 4. Now, we can also change the intercept. And what do you think this is going to do to the graph? The intercept right now on this orange graph is right here, the point 0, 1. If I move it up, notice the whole line moves up, but the slope doesn't change. So I would like you to play around with this a little bit, get familiar with it. We are going to be working with Desmos in class, and then we're going to do a little project where you just get used to graphing lines and manipulating them and finding the key parts. I hope this helped, and I hope you enjoy Desmos. Thank you.